Welcome to video lesson 11.6 on adding and subtracting rational expressions. Okay, we're going to learn how to add and subtract rational expressions that have like and also unlike denominators. Okay, basically, just like multiplying and dividing of rational expressions, adding and subtracting follow the same rules as adding and subtracting fractions. Okay, so you need to have common denominators in order to add or subtract, and then you just simply keep the same denominator and you add or subtract the numerators. Okay, and then of course simplify at the end. So what we see here is already common denominators when we're adding. We just add the numerators, keep the same denominator, and subtracting, same thing except with subtracting. All right, let's look at a few examples. So in the first one, we have like denominators of 2x, so we just have to add 5x plus 7 over 2x, and then we just see if we can simplify. Okay, so since we have 5x plus 7 and a 2x, there's really nothing that we can do to simplify this. Okay, so that can just stay like this since they're not separated out by multiplication. So that's as simplified as we can get that. Now, part B. Okay, again, we have the same common denominator, so we have 3y minus y minus 8. Okay, that's all over y plus 4. Now we're going to use the distributive property, distribute through this -1 basically here. So we have 3y minus y plus 8, because -1 times y is negative y. -1 times -8, positive 8. Our denominator is still y plus 4. And then we're going to combine like terms. Okay, so we have a 3y minus y. That's really 2y plus 8 over y plus 4. And now we can factor that out. So we can factor out a 2. So we have y plus 4 over y plus 4. Divide out the common factors of y plus 4, and we're left with 2. So we really did simplify that a great deal because all of that simplified down to 2. All right, now those were the easier ones because they already had like denominators. The more tricky problems are the ones where you have to get like denominators first. So just like with fractions, we want to find the LCD, or the least common denominator, which is the least common multiple of the denominators. So in this example, we're just going to try to find the LCD of these two rational expressions and figure out what we would want to use as our denominator. Now, in order to do this, okay, we can find the prime factorization of each denominator. Okay, so make our factor trees. Factors of 10g squared would be, well, of 10, it's just 2 and 5. And g squared, we'd have g and g. Okay, so that's the prime factorization there of 10g squared, and then 12g would be 3 and 4 and g, which is 3, 2, 2, and g. Now, the least common multiple, okay, is to multiply the ones that are in common together. So we have a 2, okay, we have a g, and those are in common. Then we multiply everything else that is left over, okay? So times 5 and times another g, and then times a 3 and another 2, okay? So we have 2 times 2, which is 4. 5 times 3 is 15, and we have 2 g's. 15 times 4 is 60. So 60g squared will be the LCD here. Okay. Now, what we need to do when we're finding the sum is first find the common denominator, okay, which would be the LCD. Okay. So we're going to factor the prime factorization of this, okay, which would be 2 times 4 times x, which is 2 times 2, Okay, we could really write this as 2 to the third power times x. Okay, and then this would be 3 times 2 times x. Okay, 3 times 2 times x squared. And then the other thing you can do is you can use the greatest power of each factor that appears in either denominator to find the LCM of the denominators. Okay, so that would be 2 to the third times 3 times x squared. Okay, so 2 to the third because that's the highest, so we don't have to worry about that too. And we don't have to worry about this x because we have this x squared here. And then we have the 3. Okay, that's another way of doing it. It's a little bit easier. Or you just circle what's in common, write that down once, and multiply by everything that's left over 2. Now 2 to the third power is 8. 8 times 3 is 24. So our LCD will be 24x squared. Okay. Now what we need to do is rewrite all of these fractions using that. Okay. So 1 over 8x, we need to get it to 24x squared. So we have to multiply it by 3x. Now whatever we do to the denominator, we do to the numerator. So that'll be 3x over 24x squared. And we'll have to do the same thing with this one. Now what will we need? So basically 24x squared divided by 6x squared will be 4. So multiply both the numerators and denominators by 4. Okay. And then we'll get plus 4x minus 8 over 24x squared. Now we'll add the numerators. So 3x plus 4x minus 8. Okay, which will give us 7x minus 8 over 24x squared. And that's all we can do. Okay, so that would be our answer. Okay, nothing else that we can do for this one. Right. One more example, finding the difference. Okay, now the easiest way to do this is going to be to factor out that denominator first. So I'm just going to rewrite this. And I'm going to factor out x squared minus 8x plus 12. Okay, that's going to factor to x plus, or we could do x minus 6, but x plus negative 6 and x minus 2. Okay, or you could just write this as x minus 6. Okay, and now, okay, because it's factored out, it's easy to see to get least common multiple or least common denominator. We just need another factor of x minus 2 on this side. Okay, so we need to multiply that first. Okay, so we have x plus 3 over x minus 6, x minus 2, minus 2 over, and we can just keep it like this really. Probably didn't need to rewrite it because we like it when it's all factored out. It's easier to simplify that way. Okay, so we'll write all of this, x plus 3, okay, minus 2, x minus 2, okay, and then that's over x minus 6, x minus 2, and we can just simplify what we have now then. So when we're doing this, okay, we can take a look at what this will all equal. So x plus 3, then this is going to be minus 2x plus 4. Sorry. Okay. So, and if we have x minus 2x, okay, that's going to give us negative 1x, and 3 minus, or sorry, what did I do here? Minus, this is just 2, so when I did this distributive property, I should just 2 times x is 2x and 2 times, so minus negative 4 here, because 2 times negative 2 would be negative 4. And then when I'm doing 3 minus negative 4, it will really be 3 plus 4, so plus 7, over then that whole denominator, x minus 6 x minus 2. Okay, and that will be our simplified version. All right, so just be careful. This is a minus sign, otherwise I could change it to plus a negative right away, and that would have helped, because then I would have had a negative 2x here right away, and then a positive 4 right here. And 3 plus 4 is 7. So that's probably the easiest way of doing that. Okay. All right, you have 5 practice problems. The first 2 have common denominators. The last 3, you need to find the least common denominator first, and then add or subtract the numerators and simplify. Okay. Please make sure you write down any questions you have. I'll be happy to answer them at the next class. Thank you. Have a great day.